Welcome to the Newton tutorial series. I'm Mike Cruz with Advanced Conveyor Technologies, and in this set of tutorials I'm going to be showing you how to use Newton. We're going to cover how to import your geometry and set up your geometry in this tab here. We're going to cover, well, how do you generate particles for your simulation, and how do you set up some of your basic friction and cohesion properties, and as well as your general simulation parameters. And we're going to talk about how to create particle sets and how to auto-generate particle sets, and a little bit of how you can create and modify your own cluster shapes as well. So this tutorial series is going to assume that you have the professional version of Newton. And if you're curious which version you're running, then go ahead and just go up to Help and About, and that's going to tell you here's your version, your build number, are you running professional or basic, here's my username, my expiration date, and so some of the features, if you watch the overview tutorial or if you've looked at our website, you know that there are features that are unavailable in the Newton Basic version. But we're going to do these tutorials with the assumption that you're running professional, so it's just going to cover all the features. So basically, the typical process for setting up a DEM simulation with Newton is as follows. The first thing you're generally going to do is you're going to go to your geometry page here, and you're going to import your geometry, and there are all kinds of different settings for, how do I import my geometry? How, do I overwrite layers? Can I scale my geometry and change the offset and whatnot? And again, obviously, the following several hours of tutorials are going to go into much greater detail about what these features are and how to use them. But for now, I'll simply say that we support the DXF format and STL format. However, with the DXF, you have to be drawing your triangles using 3D faces. So at its base level, Newton requires triangles when you're importing the geometry. In addition to importing your geometry, you can also set up to 3 different custom geometries inside Newton. So if I want, I can say, well, I've got a 1200 millimeter belt, and I know my belt speed is 2.5, and I can set up a troughing angle. By default, our troughing angle here is 35 degrees, and we'll say, well, maybe I want that to be 30 or 20 or 50, and maybe I want a 5-roll troughing angle as well. So maybe I've got 20 for the inner rolls and 35 for the outer rolls, and now we've just switched that to a 5-roll belt. If I want, I can go ahead and I can turn this into an apron feeder if I just specify the number of apron feeder plates. So let's say 60 plates, and get rid of that drop box. Oops. And now you can see that we've got ourselves a basic apron feeder, and I can control the width of that apron feeder and the length and the spacing between the top and bottom plates. I can make that greater, 1200, whatever you want. You could even set up a bucket elevator. If I simply go down here, remove my plates, import a bucket geometry. Let's see here. Where's my bucket? Bucket meshed. Go ahead and import that. And now I simply got to say, what's my pulley distance? Say 4 meters between the top and the bottom, and say 20 buckets. That's a little bit wide, huh? There we go. Oh, this got deleted, didn't it? There we go. Right there I can set up a bucket elevator and give it a velocity, and I can give it acceleration and deceleration, so I could simulate speeding up this bucket elevator. And same with a regular belt. You can simulate acceleration for belt startup and deceleration for belt shutdown. So generally, the first thing you're going to do is you're going to set up that the basic geometry, the basic movements and movement profiles and speeds. And then after that, you're probably going to go to your material generator, and you're going to say, okay, well, let's generate some particles. And how would we do that? Well, we have up to 5 different generation points, and basically you set up your basic parameters, your density, your generation method, what's your tonnage, how long do you want to generate your material. You can give your clusters some initial properties, some initial velocity or initial rotation. Then there's some advanced features here as well. And even before generating your material, maybe you want to make modifications to your particle sets, or maybe you want to create new clusters. So if we go over to our cluster creator window, you can look at all the different clusters that we have in here by default. And you can go ahead and create as many new clusters as you want. And we have a nice auto cluster creator feature where I can say, hey, let's create a 4 by 4 by 2 cluster and give it some slant in the Y and the Z direction. And we can see that just automatically created a cluster based on those parameters. So I could go ahead and use that cluster right in a particle set. Or if I want, I could say, well, I want to change the position of some of these spheres. Or maybe I want to take this cluster and I want to do some rotation. Maybe I want to, if I turn on my UCS icon, maybe I want to rotate this about the z-axis by 15 degrees. Or maybe I want to scale my cluster, say scale it by 1.2, and maybe I only want to scale the X, Y, and Z positions. I'll keep the radius the same so I can just spread out these spheres for this cluster. So you can do all kinds of things in that cluster creator. Then we go to our particle library and say, okay, now let's take those clusters and put them into a library. Put them into a particle set. We've got several built-in particle sets. We're going to continue to build upon these basic particle sets and give you more options. But you can see you can have up to 50 different cluster shapes. This one only has 43, but you could have up to 50 different cluster types in a single particle set. Each of those cluster types, you control the size of the cluster, the percent by weight. So you create a size distribution curve by controlling the percent by weight. You can look at your how does each of these clusters, how does each cluster affect my time step? So here's my approximate time step that Newton is going to use based on this particle set. And I can see, well, how many particles would I generate per 10 cubic meters? How many spheres am I going to have? 63,000. My simulation time index, this is kind of like a dimensionless parameter that says how quickly would this particle set run in a simulation compared to, say, the 50 to 150. So certainly, if I go back, the 60 to 180 is 241. The 50 to 150 is about twice as much. So that's saying that approximately, it would take approximately twice as long to run a simulation using this 50 to 150 set. And that's because we've got smaller radii. So we're going to have more particles, and we're also going to have a smaller time step because of the smaller particle radii. We can auto-generate particle sets if I wanted. Let's, I could say, well, I want 25 clusters that go from say 60 to 200, and maybe my average size will be 100. And if I click regenerate, created me a particle set right there. I can see my size distribution curve. It followed that Ross and Ramler curve. And then I could take this generated set and I could tweak all of these however I want. So I can start off with a basic automatically generated particle set and then just make changes to it as I see fit. So then, yeah, going back to the material generator, let's just create a new input file, create a basic belt. And again, let's say 1200 at 3 meters per second. Let's delete those. There we go. I've just got a basic conveyor belt, and I say, well, let's generate a 40 to 100 set right on that belt. Go ahead and generate. And it's going to tell me, oh, here's how many clusters you generated, and here's your gap between the drop layers and whatnot. And you can even preview each of these layers. I can go through and look at each layer that's going to be dropped, and it tells me, well, what time will this layer be dropped? It's going to enter the simulation at 2.691 seconds. You don't have to drop by layers. You could generate a block of particles. So if I just say, well, let's go ahead and generate a block of material at some specific location. Let's lift this up by 2 in the z direction. That shaded area is showing where am I going to be generating this. And I want to make it say a 1 by 2. Or I want to turn this into, maybe I want to make this an annulus. I can do a circle with an inner and outer diameter. And we'll say, all right, well, let's just generate the particles right there. And so it's going to generate a block of, let's just say 3 cubic meters. Go ahead and let that generate. Boom. And now we can see, wow, there's my particles that I'm going to drop here. That's 3 cubic meters of material. So you could generate in layers or as a block, or you could do it by cluster count and say how many clusters do I want to generate, or I could do it by sphere count. How many spheres do I want to generate? So then, after setting up your geometry and your particle set and generating your material, probably next you're going to go to your material properties and say, well, is this going to be a high friction simulation or a low friction? Do I want free flowing? Maybe I want to turn it up to my third notch. This is a relatively high friction, and I could go and say, well, my liquid bridge, do I want my surface tensions to be increased? Do I want to have it simulate a higher moisture content, or do I want to turn up my ratchet effect? Maybe I want to really crank up the friction for this simulation. And my coefficient restitution, maybe I want to turn that up to 0.5. So you're going to specify all of your basic friction and cohesion properties right here. And then after that, probably the last thing you'll do is set all your general parameters. You'll go to this first tab here and you say, okay, how long do I want to run the simulation? Well, I guess if I generated particles, if I go back to my layer, before this generation time was 20 seconds. So maybe I generated belt one. So maybe I generated 20 seconds worth of particles, and so therefore I want my simulation to just go to 20 seconds, or maybe I want it to go to 25 or 30. Set up your time step and critical time ratio. We'll talk about what all of these are, and your max allowed particle overlap and kill particle, all kinds of just basic parameters for your simulation that need to be set up. So that's kind of a layout of what we're going to see in these tutorials. Primarily we're working with these 6 windows to set up our simulation. And then after we run a simulation, we'll open up our resulting playback file. And then now we're in playback file mode, so now we're going to have a couple different windows. You'll notice along the button bar, we no longer have the buttons to go back to our other windows. They've been disappeared and replaced with some basic rendering options, and we have 3 new windows we can play with. There's our SMV window. What we use this for is controlling all of your basic surface and particle coloring and shading and particle style and everything like that. So if I go to steady state here, I can say, well, let's make all my layers solid, or make them all transparent, or make some of them hidden and some of them solid and some of them transparent, and whatever you want to do. I can say, well, let's zoom in on my particles here, and maybe I want the particles to be meshed. So now if I zoom in, you've got our lumpy mode where you can see each individual sphere, and then meshed mode is going to kind of mesh them together. Or if I want position tracers, skip forward a few frames. Can't do that. We'll skip back a few frames. And you can see now we're doing position tracer. So each of these lines is showing the position and velocity history of the cluster. I can set up clip planes and show and hide the different particles and the different triangles if I want. So if I wanted to, I could set up a clip plane which would completely hide everything, everything to the right of a line right here. I could say, well, I want to hide the drop box and I want to hide the particles on the feed belt here, because I don't want to show my client all of that. The client only cares about the material as it's entering the transfer chute. So why even show this? We can just go ahead and hide it. After setting up some of your layer settings, maybe you're going to want to create an animation. Using our AVI creator, you can create a keyframe animation by setting up different keyframes, and the camera view can interpolate smoothly between these different keyframes. So you could start off with a nice isometric view, and then after a couple seconds of isometric view, maybe you want to switch to a side view, and maybe you want to change your coloring or your particle styles or whatnot, and you can kind of set up an animation where you guide your client through the simulation. You start by looking at a side view of the discharge, and you kind of maybe rotate around to the front view of the discharge, and then maybe you're going to go down and show them kind of a side view of the receiving and say, okay, now here's how the material falls out of this rock box onto the belt. And then maybe we're going to switch to kind of a front view or a top view. Maybe we'll look at some belt wear. And you can do all of that in your AVI creator. And of course we have a plotting window too, where you can analyze the tonnage. So maybe I want to just set up a data box right here and calculate, what's the tonnage coming out of this transfer chute. Of course, because we only have one inlet and one exit for this transfer chute, your output tonnage is going to match the input tonnage exactly as soon as you get to steady state, unless there was some kind of buildup or blockage happening in the transfer chute. If that was happening, then yeah, you'd see that the output tonnage does not match the input tonnage. But what if this had like a flop gate or a shuttle chute right here, so we can either dump the material to one conveyor or to another conveyor over here. Maybe then we want to set up data boxes and say, okay, how much tonnage is going to each side of this receiving of the discharge. So I could, you can set up to 5 data boxes and record 5 different tonnages at 5 points in the simulation. We can look at our work. We can record and view the triangle work and the triangle forces. So I can say, well, let's just plot the work from whatever time to whatever time. If I go to this back plate, let's go to surfaces outer lines only. Turn that up. Change my back plate to work. And now, if I wanted to, I could generate a plot of the work on the back plate. So if I say back plate. Work type, well, let's just do total abrasive wear from 5 to 10. I say generate. Let's go ahead and hide the particles. We don't need to see them while this summary is going. And if I zoom in, boom, now we can see that it's starting that wear summary. It's starting to plot that wear data. So again, there's a ton of things you can do with the different post-processing features, from simply viewing the results to creating animations to creating plots. You can even save single frame playback files. If I go in here, let's stop this. If I want, I can go ahead and say save. And what I'm going to save here is basically a single frame of data at time 7.62, whatever that current time is. And that's going to save my current camera view, and it's going to save all of my layer visualization and particle visualization settings. So if we open up where that file is located, that one that we just created, date modified, this one right here, a single frame of data, we're talking 1.5 meg. I mean, this is small enough that you can email these playback frames back and forth. So rather than sending screenshots of your DEM simulation to your boss or to your clients or your coworkers, you could say, well, all right, let's go like this. Let's make my surfaces transparent. Let's make my particles visible at full steady state. I'm going to set up a custom view right here. I'm going to go to a front view. Oh, that's a back view. I'm going to go to a front view. I'm going to set up a custom view there. I'm going to go to say a back view here or a side view here, and I'm going to set up a custom view here. Then I'll go ahead and save this playback frame. Let's go ahead and overwrite that one. Now if I go there and double click that to open it up, as soon as that opens up in a moment, now you can see it saved our current view. It saved these 3 custom views that we saved, our isometric, our front, and our side. So it's just a way better way of doing a screenshot. Again, the size of this file, when it becomes decompressed, it's 2.5, but this one that we just saved here is 1.8 meg. You can email that, and you can set up 5 different views. So you say, all right, well, just give these a descriptive name, and then your coworker can look at the second view and say, well, that's a cool view, but I'm interested in kind of a different, maybe I want to look at a top view, and he can do his own orbit and rotation to whatever he wants there. But as far as the file size is concerned, this is on par with the size of a screenshot, except you have unlimited different view potential with an actual playback file. And you don't even have to have the full version of Newton installed to view these playback files. You can just install the free Newton viewer that doesn't require anything. It doesn't require a USB dongle. It doesn't have to be attached to the same network as that USB dongle for running your simulations. It can be installed on any computer free of charge. No restrictions there. And you can use it to look at these playback files. So if we go and look at what do we have in our menus, there's how do we update Newton? if I'm running some version of Newton and I want to check for updates, you click on the check for updates, you click next, and it's going to go to the internet and check with our AC-Tek server and see if you've got the latest version of Newton. And if you don't, you just got to follow these on-screen instructions. It'll download and update it automatically. We have a full user manual. You can access it right there through the help user manual. This does require that you have Adobe Reader installed. In that same help menu, we have new features. So basically, in the last few updates, it says, oh, what have we been adding in these last few updates? I think we go back, say, maybe 10 or 15 versions. So, version 2.11, we're on 2.23. This version was released 6 months ago, and you can still see, what is the progression of the changes we've made. So every time you update Newton, this is going to say, okay, version 2.23, as soon as we officially release this version, what are the changes that were made? If we go to our file menu, preferences, there's a small preferences menu where certainly we're adding new features to this with every update. This is actually a fairly new development, having these custom user preferences. We've got rendering options. Do I want to apply my adaptive degradation? Do I want to do a nice smooth interpolation between camera views and some of my default settings? Under system, do I want to enable my tooltips so when I hover I can see my tooltips, or do I want to turn that off? And similarly, hide toolbar buttons when they're disabled. I had mentioned how when we're in input file mode, all of these functions for modifying a playback file, they're disabled. So you might as well just hide those buttons altogether, and then as soon as I go into playback file mode, oh, something's already using that. Well, let's just open some other playback file. Let's just open that. You can see those input sections are grayed out as well. So there's no point in even showing it. We might as well just say, well, let's go ahead and just hide those buttons because we don't want to see them. So I think that's a good basic overview of Newton. And like I said, in these following, we've got several hours of tutorials that you can watch on this about Newton. And these tutorials are going to dive into very great detail about each of the windows that you're going to be using and how you can make those changes and how to create animations. So if you have any questions, go ahead, watch through all the tutorials, read through the manual, check out the new features, and if you can't find the answers you're looking for, then go ahead and send us an email at info@actek.com. Thanks.